We have started with drawings yesterday only. Yeah, yesterday only. Uh, and we have seen few things like drawing sheet and drawing views. Now it's time to get much little bit deeper and see something related to other components, other objects in drawing. So the important one that we usually deal with a lot when we create drawings is dimensions or annotations. So let's have a look and try to work with the dimensions. So we have created a builder already. I think we created a base view builder. Now we'll create one of the dimension builder. And before we create that, let's have a look at the API guide. There are a lot of types of dimensions. I think we have touched upon that when we have seen the namespaces related to drawings. There are a huge number of types of dimensions, and most of the dimensions, if I categorize them to simplify them, they fall under two categories. One is the kind of dimension they require one reference. For example, radius dimension, diameter dimension. So you only need one reference to create them. The other ones are they require either two or three references. The typical example is horizontal dimension, vertical dimension. So that requires two references to select. I know that even you can create a horizontal or linear dimension using just one edge selection. That's fine. That works as well. But typically, it also can be uh, created using two references. So why I'm sharing you this? Uh, I think we can get into the NX first, and then I can show you some examples of dimensions. You already knew it, I know, but we are going to see them with some different perspective. So if you see this typical drawing, we do have diameter dimensions. We do have these dimensions, linear dimensions, we can say, uh, radius dimensions even. This one is also one of the linear dimension. So these are typical three types of dimensions used here. Now, when we add dimensions via a program, via a journal in the drawing view, that time lot of things we need to take care. First of all, definitely the type of dimension that we are going to add. Then the second is which drawing view we would like to add it. Then third is the uh, the whether it is the references, the reference entity. It is drafting arc in this case or drafting curve in this case of drawing. So which reference drafting curve you will choose to draw that dimension. Third step. Then fourth is the placement of that dimension. So let's say I will create couple of more here. I will use rapid. Okay. Then first is the drawing view where I want to create that dimension. Then second is which type of dimension. Third is the drafting curves as a reference to draw that dimension. Fourth is the placement of that dimension. Fifth is whether that like properties of that dimension. For example, Yeah, we can come to that properties part. So let me select something. Okay, so this is my first step. This is the drawing view that I want to create dimension. Then second step is I am going to create the linear type of dimension. Then third step is selecting the references to add that dimension. Why it is that much slow? It's taking time. Okay, I have selected the references. Then the fourth is about the placement of that dimension. But you can see this dialog which is giving me a lot of options to work with this dimension, even including the surface finish, geometric tolerance, other tolerances. So I can even go and do that. So these are the 5 steps involved. We very easily include dimensions in our drawing, but these are the minute or fine steps that we have to take. These fine 5 steps we have to take to create a dimension. And these all steps are very well we have to take care when we create the dimension using APIs. So this is the 5 step process, and we have to define those all 5 steps very clearly in our drawing, sorry, in our program. Now, before we start, let me give you some practical experience of mine working with drawing automation. Drawing automation is most of the times is the requirement or need uh, by the team, by the company or by the project team, whatever you can call it, because this is where design engineers spend a lot of time. So they usually think or look for automating the drawing creation. And in drawing, there are lot of objects those are being created. So if you compare the objects in feature, sorry, in part or in assembly, so number of objects in part are very few. Only features, some sketches, some dimensions, some constraints. The similar case with assembly, but the number of objects and also variety of objects, typically in case of fabrication drawings or machining drawings, it is huge. So that's why the scope of automation for drawing is huge. And everything that you include, that you create into your drawing. I'm not talking about drawing sheet and drawing views. At the moment, I'm talking about annotations, being symbols, being dimensions, and everything else under annotation. So these typical 5 steps are involved. It means that we have to take care of all these 5 steps. If I tell you a specific example about one of the drawing view which needs to be and one of the drawing view where we need to add, let's say, 10 dimensions into it, into that view. So first step is identification of drawing view, so that's done. Second step is deciding type of dimension. We have to then segregate those 10 dimensions uh, based on the type of dimension. Maybe 5 are linear dimension. Out of those 5, 3 are horizontal, 2 are vertical, 3 are dimensions, 2 are radius dimension. This can be the categorization of the dimensions based on dimension types. Then then the next one, which is more complex, is which drafting curve references you will use to draw them. Then the next complex thing is that how you will position that with context to either the drawing view or the drawing sheet, because you also need to take care that they are well placed, neatly placed, and they are not overlapping with something else. So Creating every single object of this sort takes a lot of efforts. It involves a very strong and uh, foolproof logic, as well as we have to deal with lot of references in the drawing view. So because of this aspect, because of this scope of drawing automation is compared to part and assembly, it is too much lengthy to automate, and it also requires the next level of expertise than a typical CAD developer. So here, yeah, you need to be someone who is very well expert and very well uh, experience to work on the typical drawing automation. I'm talking about creation of drawing type of automation. So where you draw the drawing sheets, where you draw the annotations to the drawing views. So I'm talking about creating this kind of automation where you create the drawing from scratch. And again, at the end, there is limitation to how these drawings are fulfilled or completed percentage wise. You cannot aim to complete the 100% drawing by automation. Even if you do have a very standard set of drawings, very standard set of design that you prepare, a very standard set of annotations, and you do have a minute details available where you can exactly uh, list down all the different types of dimensions per view along with all the details of that. But still, it is not it is not possible to automate 100%. Rather, I would say, with my experience, it is a wrong intention to have when you try to automate 100%, because there is a at least 5 to 10% room for improvement, or room for uh, the manual intervention by a engineer, by a human, because you cannot aim to automate everything. If you aim to automate everything, then you might miss on something which can create a quality error. Okay, so these are the two aspects. To summarize, one is drawing automation is something should be done by an expert CAD developer, and it takes lot of time, lot of logic preparation is involved. And second is always no one shall not aim to automate the 100% try. Okay, so with this, let's start with one of the example where we can go and add the dimension. Now we can move to this other drawing, which is again a very simple model. It's a cube where I have added the, I can show you. It's a tool where I have added a radius on one of the edge. What we are going to do is we are going to add the radial dimension. So why radial dimension again? Because considering those 5 steps to add the dimension, which is very simple to start with, because here only one drafting curve reference is required for us to consider. Uh, of course, the drawing view itself is known. We can use this drawing view because this has a very visible side where we can see this arc. And what I have done is I have even uh, made the job simple by adding the name to the edge, because we are going to select that edge. And let me show you edge. If I right click and see the info for this, there is no name for this. I think it is other one. Uh, I do have a name. Let me see if I do have a name to face. Okay, I think it is in the drafting itself. You can see this right click. Okay, so I have added the name in the drawing itself. So I have added the name radius to the drafting arc. So why I did this? Because it eases my job. So picking up the reference drafting curve will be easy with the name. Then I don't need to create a logic, scan all the edges, and then with some logic find out the relevant arc to add the dimension. Okay, so this is the actually we are giving the input to our program to to create the correct dimension with the correct drafting curve reference. Also, as I am going to create the radial dimension, I only need the one reference. Okay, so this is some pre-preparation done, so that is going to help the code preparation. Now we'll go to Visual Studio. What we do is mainly it's going to the thing that we are going to do is the example that we are going to look is to create the radial dimension, right? And we know that for creating a typical object, we need to do it through Builder. So maybe we can have a look quickly at the API guide. And there are several builders because there are several uh, type of dimensions. So radial dimension builder I'm going to see. This is under annotations as well. Uh, this is under annotations rather. And this radial dimension builder creates a radial dimension. It is that simple. We don't need to look at these members of this radial dimension builder because these are not that much important for us. Rather, we have to go through either this or the recording of a journal to understand what parameters we need for creating that object. And we also know the standard 5 steps for creating a builder. So we can take help of that to initiate this builder. Now, let's get into the Visual Studio. I do have a journal recorded as a reference so that we can go and review that journal, understand the required parameters within that within that journal, and modify it or clean it up accordingly so that we do have our own code that works and that creates the object that creates the radial dimension. So I do have this code. Uh, this is the recorded journal, and you can see this is huge journal actually. It contains huge lines of code. We will go through this quickly, and then we'll also see how it runs in in next session. So our builder starts from here. The dimension itself is declared as one of the variable. Then the builder is declared, and then this create radial dimension builder is initiated using the output object. Using the output object, this one is being output object. So these 3 steps are very standard. Then fourth step is to define the parameters clearly so that we do have all the necessary parameters with necessary info very well defined to create the radial dimension. So this is even includes that parameters. Huge set of parameters are there. Actually, there is lot to clean up here, but this is nothing but the parameters. It also covers the reference to use. If you can see, it also covers the drawing view where that dimension is going to be placed. It also covers the drafting curve because that drafting curve is required as a reference to uh, add that dimension. There is also a point 3D, which is I think denoting the location or the placement of a dimension. And this is associativity, which actually sets the dimension. And at the end, after all of that finished, the usual line is to commit and destroy the builder. But you can see there is lot much of lines of code which are unnecessary here, and we as usual can go and clean up that. So our code will look tidy, but cleanup is just half way done because cleanup can only do the halfway things for us because we have to do lot more other things. The important one that I'm going to share with you now because because this is something which we have seen in the one of the earlier session as well. This find object API is not something that we shall use in our code because this is very specific to journal recording, and this is not going to help us. Okay, but maybe I will try this for now to show you how it works in NX. I'm not sure if this will work, but still I will try. I will attempt it. My journal language is set to C sharp. That's fine. Then new journal. I have pasted this recorded journal and it will try to run it now. It shall create a dimension here. Let's see if it works. If you have recorded a journal on the view or the drawing sheet and you have not changed anything there, it obviously runs when you execute it. So it is because all the references are intact, all the things are intact, even the dimensions and the not dimensions but the drawing sheet, drawing view is intact. So that time it works. It's not working for me because of some reason. Maybe something I changed on this part file after I have recorded it. I have recorded in last time, so maybe that's the reason it's not working. But I'm not going to spend time on making sure that it works because we have to uh, clean it up a lot and we have to also modify a little bit of code to make it work. So rather than uh, spending time on this journal itself, let's uh, dive into the Visual Studio and try to clean it up and also modify it so that it works. So inside Visual Studio, what we will do, we will first focus on getting this section right, this particular code block I am talking about. So we have seen in one of the example, what we have done is rather than picking up the or using the same code where the find object APIs are used, we have written a for each loop and we have found out that object so that we get that object collected out of the NX itself. rather than depending on find object API. So we are going to do the same. Rather than using find object, we will use for each loop to find these objects from the NX active part, or a drawing, you can say. So here your knowledge of CAD is little bit plays a role. For example, uh, first comes the drawing sheet, then comes drawing view, and then comes the dimension, right? So these are the objects which are like these are the levels how we access the typical object, or this is the relationship of that dimension that has in place in that drawing document. So drawing view and the associated drawing sheet. So why we are fetching this? Because this is the required parameter in the builder. So that's why we need this. So we need mainly we need the drawing view. I am not sure why this drafting body is here. Drafting body, I think we can ignore. So what we need is we need a drawing view where we want to place that dimension, and also we need the access to that drafting curve, which is named as radius. So we need to have that uh, objects picked up from the session. And how we are going to do that? We are going to do that using the uh, for each loop. So I will start. What we can do? We will start a for each loop with drawings. So uh, this is all actually a lot of that we can clean up, but I will leave it to you because you have already seen me cleaning up a couple of journals already, and you can spend time on doing this rather than I spend time on this. I will focus on something that is really important to focus on. So what I will do is I will write the required variable. First, I would like to access the drawing view. So for that, I will first get the collection of drawing views, or I can straight away go and write the for each loop. So okay, so I will not go and straight away write the for each loop. I will first declare the variable. So I will declare it as drafting view, and that I will declare as array, and then its name df view, df view is equals to work part dot get drafting views. So it's very easy to get the drafting views. Get drafting views. I'm not getting this API. Let me check. Yes. Here I need to import the drawings library. Now I can use this get drafting get strange. Okay. Sorry, I think it's not under work part. It is under worksheet. I can go and show you this into the API guide. Inside the drawings, we do have drawing sheet, and here we do have this get drafting views. So this is what I am going to use. It returns the drafting views on a sheet. So for that I need the sheet first. It is not a part of work part, it is a part of the sheet. So I have to first define the drawing sheet. If it is not there in my journal, then I have to initiate it. It doesn't look like it's there. So I can go and define those variables even. So drawing sheet collection. I will I will start with the collection itself. I will name it as sheets. Then work part dot drawing sheets. So now you can see the hierarchy is being followed. Work part has drawing sheets, then drawing sheets has drawing views, and then drawing views has annotations or dimensions. So this is the typical uh, hierarchy being followed. So we have to also know that it's a common sense to know actually. Drawing sheets. Okay, I do have drawing sheets now. So it is a collection of drawings. Now I do need the active sheet. So how I can get that? I have to first declare the drawing sheet. I will write it as drg sheet is equals to sheets dot current drawing sheet. So this is how I get the current drawing sheet. Now once I get the drawing sheet, then I can get the drawing views. So instead of work part, what I will do is drg sheet. Here I cannot use sheets variable because sheets is actually collection of sheets. So I am not bothering about collection of sheets. I do have a current sheet and I wanted to access the specific view from that current sheet. So that's why I will use drg sheet dot get drafting views. Now this will get me all the drafting views in that sheet. Okay, now it is done. Then I can go on and declare the next. There is something here. I cannot convert get drafting views to drafting view array. Something maybe there. Oh, I am actually missing this bracket. That's it. Okay, now I can initiate the for each loop on the drawing views to find out the drawing view with this name ortho at 2. So for each, then inside bracket, I will name it as drafting view, df view I will call it. Inside this collection, it's a collection of drafting views and bracket complete. Now I will have these brackets to write the code block for each function. Now once I got the drafting views, I will look for this name and I will use that as the drafting view for my uh, builder. So this is actually projected view. So I can actually copy this variable name as is here. I have declared it, so I can go and delete this line. So it is declared. So what I will do is I will have the condition if inside bracket df view dot name is equals to ortho2. So I am accessing this ortho2 from this for each loop, and this is typical method that we have followed in many examples. So you should able to understand it. Now uh, now we do have the condition to set. Okay, I have to use double equal sign because I'm comparing. So if this view is we found with this specific name, so what I will do is simply I will assign the object to this variable. So this variable which is having the ortho2 name to that view, we are assigning that to our variable projected view, which is used in this builder. Okay, because we have to pass on the information from for each loop to the variables which is declared and used outside for each loop. Because if because this df view variable, the scope of this variable is limited to the for each loop. It has no meaning outside this for each loop. So this is why we need the variable outside for each loop, and we need to pass the value of the variable from for each loop to the outside variable so that we can work with that further. So that's why we have to pass on the value of this df view to projected view 1. Now you can see one error here. It says that cannot convert drafting view to projected view. Now you will see what is this confusion. Drafting view and projected view. What is the difference between two? And ideally they shall be similar type. Why these are two different types? So don't get into too much of these questions because this will increase your confusion only. Rather than try to see it in simplified way, we know by common sense, by logic, drafting view and projected view are nothing but same. We know that there is something called base view or a parent view, and there could be several projected views to that. But as the projected view is used in this builder, then we can convert this drafting view which is found by for each loop. We can convert that into projected view and use it. This is the simple way we can do it. Now another question you might come across is why projected view is only used in builder. It shall be actually some other view as well, because other views like base view, section view, or any other view can also have the dimensions, and we can even go and create the radial builder for adding that dimension for other type of views as well. So it's fine. So what you are thinking is right, and that should be happening, or it is that way it shall happen. But it is recorded journal, and recorded journal, you can understand, it follows a typical uh, way to script the journal, and then that's why it is projected view used. You can go and change that, but that's a latter part. Means you we have to first get focus on getting these objects right. Maybe as a part of further fine tuning, further improvement in your code, making it generic, making it simplified one. That time we can think of replacing projected view with some common uh, type of object for a view. But for now, let's just convert this into the projected view. So what we are going to do is we are going to convert the drafting view into projected view. So it's very easy. So we have to explicitly mention the conversion, and then this conversion will happen. So how we do it? NX NXOpen dot drawings dot projected view. So we have to mention the type where we want to convert this into the bracket space followed by that object. So this way we can explicitly convert the drafting view into projected view. Explicitly meaning we are specifically mentioning that into our code that we need to convert the drafting view into projected view. And now this way we have taken care of that conversion problem. So this is how we got the drawing view object. Now we have to get one other object which is the drafting curve that is named with name radius. So we have to also access that. That is a another important requirement for our builder. So for this we will surely need the nested loop, and uh, nested loop, I think we have to start the from the bodies. Let's say I will try to get the drafting curve directly instead of bodies. Drafting curve, DF curve, I will name it inside uh, DF view dot. Let's see if I get all the drafting curves from the view itself. So I must be getting that, but let's see drafting curves. So what my view class contains, so this is the drafting view. Okay, if I go inside the drafting view class inside NX, drafting view, what I'm looking for, I'm looking for API to get all the drafting curves of a view. So let me find curve here. You can see this curve parameter, this curve keyword is not at all present in this class. Now for validating the same thing, I will uh, go and check projected view as well. Let's say this class I will check, and I will also check for curve object or curve keyword. It is not here even, but let's see bodies. You can see we do have drafting bodies. It returns the bodies collection, drafting bodies collection. And if I get into drafting bodies collection, then uh, is here curves are there. Here as well, no curves are there. So where we can find the curves? That's I think it's not under drafting body collection, because we have to then iterate through each body one by one to get the curves. It should be into drafting body, not into body collection. Let me see this class. Better if I go and search it. Yeah, here it is. drafting curves. It returns the drafting curves collection. It means that within drawing view, we can first access drafting body, and then from that body object, we can find drafting curves. So this is again the hierarchy, how it is the hierarchically placed, how these objects are interrelated. So this is the hierarchy of the same. So we have to first write our for each loop on bodies, and then within within each body we can find out the drafting curves, and then for each of the drafting curves that we find, we can compare the name with the name that we are looking for, and this is how we can get the drafting curve object. So this is uh, the way we have to do it. It means that we have to first write the loop for drafting body, not directly we can start with drafting curve. We have to first start with drafting body, and that too in this view as drafting bodies. Okay, so we have done. Now another nested for each drafting curve. Now I can go with the drafting curve in df body dot drafting curves. So this is how I can go and access curves. Now when in this for each, I do have a if condition similar to this. What I am going to do is if drafting curve dot name matches the name radius, then I will use that object as a parameter for my builder. So that is going to be the drafting curve. So I will also go and do the similar thing. I will declare this drafting curve variable on top, just below the projected view, and will correct this specific line. And then I can use this collect the object. So we can use this df curve and assign that to drafting curve 1, so that we can have it further in our builder as a parameter. So this is done. Now you can see we have done with projected view. So this specific line we can comment. We have done with drafting curve as well, but you can notice drafting body is also used to find object here. I'm not sure if that is still a part of builder and we need that. We can go and check if it is needed. It won't, I'm not able to find it if it is used somewhere else apart from this line. So I think we can ignore it. We can directly go and comment this line. Uh, we can even actually we have to comment all these three because we already have these three objects from this exercise. We do have this nested for each loop. We have three loops, one inside another, and we are finding out the required objects that we need to use as a parameter in our builder. Okay, now still this is giving some error. unassigned local variable. Actually, this is assigned, but this is uh, with some condition. Actually, what happens is when we have if condition, so we are checking for the specific thing, and if we found that specific thing, then our variable will have a value, and some value will get assigned to that variable. But what if that specific condition is not met? Then there won't be anything assigned, right? So that's why this error is. This is what the meaning of this error is. So it says unassigned variable. So we have only seeing one side of our program where we got the object, where we got the required object, provided this condition is true. But we haven't mentioned anything that if this is not true, then what will happen? So there are one simple way to tackle this. We can provide the null value to the variable when we declare it. It means that our value, though null means empty, null means nothing, but still null is some kind of value that's assigned to that variable. If this condition is not met, at least there will be a null parameter to this variable. If it is null, definitely our builder is not going to work. But still, uh, at least at this point of time before execution, our program understands that it is fine and it will not give us any error. Maybe our program will not work, but still, at least for the sake of this code here, it will not give any errors. Okay, so this is what we have to do to find the relevant objects in a proper manner, because we cannot use find object lines in our code. Okay, so this is the important thing that we have to take care and make sure that we got the required parameters to make our program work. Now, little bit on this journal, you can see this dimension units, huge number of lines are there. This is simply we can go and clean up. Okay, and there you will find a lot of such kind of things in this journal which you can go and clean up. For example, these strings, even these are actually not required. What is the meaning of this? Because we can think of think logically, adding the curiosity. Why we need the string to add the dimension? These too many strings are not at all required. Maybe when you record it yourself, you will get some other codes of line which will be different from this. But this is logic, something that you have to use to clean up. And I guess you have already knew it a little bit because we have done this exercise at least twice, cleaning up the recorded journal. Okay, so there is lot of lines of code that there is a possibility to clean up that. Uh, and what else? Huge list of those kind of parameters which can be cleaned up. Again, I think this is the duplicate. It's coming lot of times. Even this all call out setting builder, we don't need it at all. So we have to clean it completely. We have to clean it completely. Okay, and and then you can see there are two radial dimension filters captured in this journal. We don't need two, so we can simply delete this number two builder straight away. This will clean up more than 50% of our code. So we don't need this builder number two at all. Our builder number one is getting uh, committed and destroyed here, and that's it. So this means that all the code below this becomes irrelevant for us. So I can go and delete this entire code even. Okay, now I will keep it as is, but this is something that you can do to clean up the code. Now this will get me the required objects, and I think my code is going to work with this. So I do have the cleaned up journal that I will straight away show you now. Okay, the same logic is used. We do have the for each logic which we have used to fetch the required details, and this is the cleaned up code where we do have only the required parameters for that builder. Now important of these all parameters, those are required for creating radial dimension builder are uh, this associativity. You can notice there are two ways the associativity is defined. So associativity meaning the relation uh, of the object, the dimension object with the drawing view and with the drafting curve. Actually, drafting curve and the drawing view itself are actually very important parameters to create that builder, and that objects are assigned to the dimension using this API or this specific line. So this is the associativity of that dimension being made with the drawing view and that drafting curve. Okay, there are two ways it is defined. Probably only one of these is required. Projected view drafting curve is mentioned here. Actually, it is mentioned in both of the cases, and only one of these is required probably by my gut feeling. But I kept both of them here uh, for now because that is again the part of trial error that we can do. Give me a moment. I will back in few seconds. Yeah. So yes. So this is the only important parameter that is very important to create that dimension. Others are very simple and straightforward to understand. For example, anchor point, which is set to mid center. Then this is some relativity with respect to geometry. Then this is about the direction. Again, this I'm doubtful whether we really need a dimension. This point 3D, it actually denotes the placement of the dimension. And leader orientation is set to right. Text center is if it is true, it will be on the center. So these are only few other parameters that those are very easy to understand. I think that's all about this example, and I will try to run this now inside a journal. I'm not sure if it is still will work. Most probably, I am hopeful that it will work because the only doubt that I have is there are still some journal specific things. For example, this point XYZ coordinates. All these are coming from the custom recorded journal. So maybe this is something that I need to change if it's not working. But for now, just let's try this. Cleaning up of that journal, making that journal a generic one, which helps actually because journal are very specific to that recording, that session, that environment, and all of that. It will not work in the other environment. If we slightly change anything, then it will throw an error, and we were not able to what I can say, we were not able to tweak that, we were not able to correct that. But what we have learning or what we are focusing now, if we follow that, then what we are making sure is that we are not bothering about the environment. We are not bothering about the we are not bothering about the setup that is used to record the journal to make it work when it is executed again. So when we do the cleanup like this, actually what we are doing is we are only picking the reference as a journal, as a recorded journal. But we are trying to see that made, we are making it in a way that which will work in the situation based uh, on the generic situation, I would say. So what we do is we actually try to make that program that works in the generic situation. Generic means it is not specific to the specific aspect or specific environment or specific setup. I think this has worked very well. We have got this dimension placed. What I mean by the specific setup or the specific environment is, let's say I do not have this drawing view here. I have it on some other location, or I have it with some other scale, or I have it like this. So it is not at the same place. So if this is something which is change in the environment for journal, and if you run it to your journal in this case without modifying it, it will not work. Most probably it will not work. But if you modify the program like this, what we have learned so far, then it makes sure that it works without fail, because you are dealing with the real objects which are available real time there. Maybe if our code is not working, that the probable reason could be that ortho 2 is not there. It's with some other name. So we have to only go and change that name so that it starts working. So it is then object specific things that we have to tweak, or we have to take care. But the things like this, we don't need to take care, like change in scale, change in position. So all those kind of things. If this drawing view is not on sheet one, it is on some other view, other sheet, then what we have to see is we have to only make that sheet active, because our program is going to work on the active sheet. Our program is not bothering about whether there is a sheet one or not. Our program is more bothering about whether there is a active sheet with that specific view is there or not. So this is what I mean by the environmental things, or the setup part. And this is where the journal, recorded journal, and our own from scratch created journal. This is a difference between two. Okay. With this, we are closing today's session. I think it was fruitful, because though it was the typical thing, we started off from the journal, but I tried to give some different perspective that helps in understanding more about the not just topic, but in general understanding, improving understanding about the APIs, how to use them, what method, what approach you can take to prepare your journal and all of that. Okay, so that's fine. We are done with today. Thanks a lot for being till the end.